Number 72. Using the exact exponential treatment, find how much time is required to discharge a 250 microfarad capacitor through a 500 ohm resistor down to 1% of its original voltage. Alrighty. So we have to use the discharge formula. It says that the voltage at some point in time, after this thing begins discharging, is equal to then the original or the initial voltage multiplied by base e to the negative elapsed time divided by the resistance multiplied by the capacitance. So what we have to find here is we have to find time, right? That's what we got to find. So how do we solve this thing for time? I'm going to do it mathematically. Divide the right side by the initial voltage, divide the left side by the initial voltage. We'll see you later, initial voltage on the right. And now what we're going to do is we're going to have this little, or now what we're going to have is we're going to have this little fraction on the left-hand side. It's equal to base e to the negative t over RC. Now I want to find time, remember, so therefore I'm going to have to take the natural logarithm, because the only way for me to get rid of the e on the right-hand side is to take the natural log, and whatever you do to the left, you got to do to the right. So now this looks like ln of Vt over Vo is equal to then negative t over Rc. And now notice, all I got to do is just do a simple cross multiplication to find time. In other words, just move this R and C on over to here. It's a negative, and just move that too, right? And look, beautiful, right? So this is it. This is the formula now. Okay, you can put another parenthesis around there if you like, and there it is. So now it tells us that if I can find the ratio between the final time essentially and the initial time, I can find my answer. I also need to know the resistance and the capacitance. So do they tell me all that stuff? Sure. Here's the resistance, here's the capacitance, and here's basically a percentage change, but we're going to have to convert that into a fractional change, all right? Remember, anytime you want to you got to divide this by 100, all right? You got to, or just move the decimal 2 places to the left. You know that, right? Whenever you're doing a calculation, you can't plug in a percent. You got to plug in the decimal, and you just got to move that decimal 2 places then to the left, or divide this value by 100. So 0.01, that would have been the fractional change. And this would represent then the final value relative to the initial value, right? Think about it. If you started with $100 and you were left with $1, right? How much? What's the fractional change? 0.01, right? Multiply that by 100, then and you get 1%, right? So basically, when you're left with $1 and you start with 100, 1% of its original value is $1 if you started with 100. Not really sure if that made sense, but hopefully it did. In any case, all I got to now do is plug in my value. So we got negative resistance, so 500 ohms. We don't have to do any conversions. Actually, maybe I'll do it down here. I'm just plugging in the values now. Negative 500 multiplied by that capacitance of 250 microfarads, but you know we need that in farads, so simply multiply that by 10 to the minus 6th. Then take the natural log now of this fraction, or this decimal, right? And that will equal your time. So negative 500 times 250 times 10 to the minus 6th, multiplied then by the natural log of 0.01. And notice it comes out positive, 0.576 seconds. That's how much time. Guys, thank you so much for tuning in. I appreciate it. Please remember to help us out and subscribe, and I will see you soon. Take care.